In this lecture, the objective is to grab the file from the drop event. We'll prepare the file before initiating the upload. Let's jump right into it. We'll continue working in the upload component. The first thing we need to do is grab the file that was dropped onto the element. The drop event we're listening to will pass along the files that the user dropped. We can retrieve the files by using the event object. In the template for the upload component, pass the event object to the upload method. Vue creates an object called event. We can pass it to our methods if we choose to. The event object is the same object you would come across in any other JavaScript event. Vue will call it event so that you can pass it to your methods. Down below in the upload method, we'll accept the event parameter. Inside the function, we're going to log the event object. We want to check out what's inside before we move on. Next, we'll switch to the browser with the console opened. Drag and drop a file onto the uploader. Inside the console, the event object is logged. Opening its contents will reveal a long list of properties. The one property we'll want to focus on is the data transfer object. This object will contain the contents of the files transferred. There's a property called files. It's an array of files that were dropped on the element. However, if we look at the files property, it'll be empty. This output is very mysterious because we did everything right. You may assume there's an error in our code, but it's actually not our fault. For one reason or another, Chrome will not log the files unless you access the files directly. Let me show you what I mean. Let's go back to the editor. We're going to create a variable called files. It'll be set to event.dataTransfer. Next, update the log with the variable. Going back to the browser, we'll drop a file onto the uploader again. Just like magic, the files property is filled with information related to the file dropped. This error is a gotcha with Chrome. If you're trying to debug drag and drop operations, you need to access the properties directly to see their values. Simply logging the object, in general, will result in an empty array. It's a weird bug in Chrome, but I thought I'd let you know just in case. Moving forward, we can begin to use Firebase to start the upload process. Firebase allows us to upload multiple files in parallel, but they need to be passed in one at a time. Here's what we'll do. We'll loop through the files in the event. In each iteration, we'll send the file to Firebase. Firebase will send back a response which we'll handle. This is where things get tricky. The files array is actually an object. It may look like an array because the keys are numeric, but it's not an array. We don't have access to the looping functions that come with the array object. We'll need to get creative by converting it into an array. We'll update the variable definition by wrapping the event.dataTransfer.files property with square brackets. Then, we'll add the spread operator before the value. This syntax is a clever way of converting an object to an array. We're spreading the object properties into an array. This will allow us to use the array methods. We'll call the forEach function on the files array. Pass in a callback function. The callback function will receive the file in each iteration. There are three parameters, which are the file, index, and array. We don't need all three. We're going to add the file parameter. Next, we'll want to perform validation on the individual file in the loop's current iteration. We want to check the file type. If the user attempts to upload a file other than an audio file, we'll reject the file. Validation can be performed in Firebase, but as an extra precaution, we'll perform it on the client side. Inside the function, create a conditional block. The condition will be the following: file.type does not equal audio/mpeg. I quickly want to go over MIME types. A MIME type is a label to help identify the type of data in a file. They're similar to extensions, except they can't be changed easily. It's more practical to check for a file's MIME type than it is to check for the extension. MIME types are formatted by their type and subtype. A slash separates them. The type is the general category a file belongs to. This is why you may see some MIME types with similar values. Audio files are assigned under the audio category. The subtype is the specific type of file. This part of the MIME type is where most MIME types differ from one another. I've provided some examples of MIME types. For this course, we're going to be checking if the file is an MP3 file. Other audio file types can be used. In the resource section of this lecture, I provide a link to a Wikipedia page with information about what audio types are supported in which browsers. MP3 files are generally supported in most browsers. Some browsers will not support certain file types due to patents or licensing issues. We'll keep it simple by limiting support to MP3 files. Back in the editor, we want to check if the MIME type isn't audio/MPEG. If it isn't, we'll return the function. This return statement will end the current iteration of the loop. If the user makes it to this point, we can begin to upload the file to Firebase. We'll start handling the upload in the next lecture.